Hello students, I hope you all are doing well. So let's start today's lesson, lesson number 2 of this unit. And here in this lesson we are going to learn about various aspects related to simultaneous occurrence of two or more events. Okay. So if you remember in the previous lesson I just told you that this P of AB represents probability of the happening of A and B simultaneously. Okay, so in the same way, like we have some notations, like if I write P of A, so it represents probability of happening A. If I write P of A plus B, so it represents what? It represents probability of happening either A or B. So in the same way, this P of AB represents the happening of A and B simultaneously. Okay, so we need to learn these standard notations, because these standard notations have a literal meaning. Okay, so here now I'm going to tell you, whenever we deal with these types of events, when two things are happening simultaneously, so sometimes some conditions are imposed over there, and these conditions gives rise to the new definition of conditional probability. So here the definition says the probability of happening of an event A when the event B has already happened is called the conditional probability. Okay, see, we are talking about two events here, but here there's a condition that one event has already happened, and now we are finding the probability of happening of another. So these type of probability are called conditional probability, and we use this type of notation to denote this conditional probability. And here this notation P of A, this divide sign B, represents that probability of happening A when B has already happened. Okay, so whenever it is written somewhere that P of, say, suppose A and say D, so you must understand that this is representing a conditional probability that D has already happened, and now we are looking for the probability of happening A. Okay, so I hope this is clear. Now there is one another point which is related to dependency and independency. So that this is very important. You should learn this thing also, because here see, two events are said to be independent if the probability of the happening of one does not depend on the happening or non-happening of other. Okay, so this is the definition when we again talk about the happening of two events simultaneously. So this concept is very useful to consider, because sometimes these events are dependent, sometimes these events are independent, and sometimes these events are mutually exclusive, which we learned in the previous lesson, if you remember. So if the events are not related, so those are independent. If they are related in any manner, those are called dependent. And if happening of one event ruled or control the happening of other event, that is called mutually exclusive. Okay, so these are the points we need to keep in mind. Now let me summarize what are the main points we have to memorize whenever we are solving the problems related to probability. So here the first concept is, if A and B are two events, then probability of happening A and B events, okay, simultaneously is basically equivalent to either this or this. Okay, and you can understand this is the probability of A and probability of B when A already happened. Okay, this is the probability of B and probability of A when B already happened. So this is either equivalent to this or this, depends on the situation. Okay, and this particular formula or relation is called basically multiplication law of probability. Fine. The second main thing is, we have to keep in mind that if these two events are independent events, then this formula is equivalent to basically this. That means simultaneous occurrence of event A and B AB, and the probability of AB would be equivalent to probability of A, and that means product probability of B only. Because here these are not these are not dependent, these are independent. So this probability of happening B when A already happened is would be equivalent to probability of B only. Okay, and this thing would be equivalent to P of B or P of A. Okay, so this is the next point. And if you remember in the previous lesson, we learned these two main concepts, that if two events A and B are not mutually exclusive, then we use this formula to just get the probability of either A is happening or B is happening. And here this P of A represents what? The occurrence of A and B simultaneously. Okay, if something is common, then we will use this thing. But if two things are mutually exclusive, then this P of A goes to 0, and we use this much formula only. So that means this P of AB, okay, P of AB, which represents the simultaneous occurrence of two events, is equivalent to 3 formulas. Okay, one is this, second is this, and third is this. Depends on the situation. Okay, so this is whole about, we have to learn, and we have to practice these concepts. Okay, now I will take a few examples, different examples, so that we can learn how to apply all these concept definition in solving problems. Okay, so here is my example number 1. Okay, so just a minute. So this example or question number 1 says, a bag contains 10 white, 15 black balls. 2 balls are drawn in succession. What is the probability that first is white and second is black? Okay, so if I solve this problem, so I will just draw a bag first of all. Okay, just a minute. Yeah, I will draw a bag, and then I will put these 10 white balls and 15 black balls here, and we are looking for 2 balls, but in the succession, one after another, and we are interested in the probability that first is white and second is black. So first of all, we will find the probability of a white ball. So probability of white ball is would be like, first of all, white ball will come from these 10 balls, so we will write 10C1 divide by total are 25, 25C1. So this is the probability of getting one white ball. Okay, now and now that means we will use this multiplication sign because of this and. Okay, now second ball is black, so second ball which is black we are demanding, that will come from these 15 balls. So we will write 15 out of these 15 C1, we will get a single ball here, and now remaining balls are 24 this time, because we have already drawn, so 24 C1. So see, this is how simple it is. We are just using the word, we are just using the notations word by word. Okay, so this, if I will solve this, this will be my answer. But this thing is perfectly fine when you solve multiple type of questions, MCQs. But if this question comes in your examination, then you have to write in a proper way. Okay, so you have to write in this way, like probability of drawing one white ball is 10 by 25, probability of drawing black ball without replacing this this thing, and then required probability is this. You have to use proper language. Okay, now let's move to the another example, and here an urn contains 9 balls, 2 of which are red. So I will again draw a urn or bag, so in which 2 are red, 2 are red, okay, and 3 are blue and 4 are black. And now 3 balls are drawn from the urn at random. So what is the probability that first question is the 3 balls are of different color. So that means different color must be that means one is white, one is black, and one is blue. So say this is blue and this is black. Okay, so one from each color we must have. So what should be our answer directly if I write? So out of 2 red I need 1, and out of 3 I need 1, and out of 4 I need 1, and total out of 9 I am drawing 3. So this is how I can find my answer, but in examination you have to use proper language. Okay, and the second part, the 3 balls are of the same color, so that means I have two possibility, that either these 3 balls will come from blue balls, or these 3 balls will come from these black balls. So either or, I have to use that addition law, probability of A plus B. Okay, so here what I write, first case is, suppose all those 3 balls are what, blue. So my answer would be 3 out of 3 blue balls, 3 are I'm getting, and total are out of 9 I'm getting 9. Okay, for the black, or for the or, I will get plus sign, and here 4C3, and total out of 9 I am getting 3. Okay, so and nothing would be the common because these are two mutually exclusive, so this would be my answer. But in the proper way you have to use the proper language in this way. Okay, you have to write properly in examination. Okay, so I hope now you have understood. Now this is this is the concept we use, mutually exclusive, and the simultaneously different colors. Here is different example, and in which we have basically 3 groups of children, and here say suppose one group, it contains 3 girls and 1 boy, and in the second group we have 2 girls and 2 boys, and in the third group we have 1 girl and what, 3 boys. Okay, now question is, one child is selected at random from each group, find the chance of selecting 1 girl and 2 boys. Okay, so we have to think in every perspective, like how can I get this type of situation, 1 girl and 2 boy. So I have total 3 cases. Case number 1, is 1 girl from here, okay, girl from here, boy from here, and boy from here. So this will solve my purpose. The second case is what, boy from first group, girl from second group, and boy from third group. Okay, and the third case is, case number 3 is 1 boy from first group, boy from second, and girl from third. Okay, so these are 3 possibilities in which manner I can get this selection of 1 girl and 2 boys. So I have to find out the probability of each case, case 1, case 2, and case 3, but these 3 cases are mutually exclusive, so ultimately finally we will add all those probabilities. So here is the solution of this problem. You can see first way. Okay, so first way you will get the probability, then second way you will get the probability, third way you will get the probability. Okay, and finally these are mutually exclusive, so here see, we have added all these probability and you will get your answer. Okay, so this type of this type of problems you can solve through this method. Fine. So now let me take another example, and it is very interesting, and it has many concepts. So here, just a minute. Okay, so in this example you can see the question is, a husband and a husband and a wife is appear in the interview for 2 vacancies in the same post. Okay, the probability of husband's selection is 1/7 and the wife's selection is 1/5. What is the probability? Number first question is, both of them will be selected. So that means what will be the answer? That both will be selected, that means husband is selected and wife is selected. Okay, so this would be the answer. Second is, only one of them will be selected. So that means either husband will selected or wife will be selected. So we'll get like if husband will selected, definitely wife will not select, okay, or for this, or this is plus sign. And the second case is if wife is wife is selected, then husband will not be selected here. So this is the mutually exclusive case, and likewise you can get the answer. The third is here, the none of them will be selected. So neither this husband is selected and nor this, this uh, here you can use this thing, that husband is not selected and wife is also not selected. So this and or, you have to use these no the symbols. For like for and you use this multiple sign, and for or you use this. So if you will go word by word, and you will then you will be able to solve the probability problems, okay. And here if the question comes at least one is selected, then you have to use this concept, okay. So probability that at least one of the events happens is 1 minus p1, 1 minus p2, 1 minus pn. What does it mean? See, if p1, p2, pn are the probability of happening, then 1 minus p1, 1 minus p2, 1 minus pn will be the probability of not happening, okay. And finally, if these all are not happening and we are subtracting this thing by minus 1, then you will get the probability of at least one of these events happen, okay. So here you can use this concept. If we want that at least one should be selected, so you will just write 1 minus 24 by 35, okay, and you will get your answer 11 by 35. Fine. So these were the total cases of both selected, one selected, not selected. So you have to be very careful. Please practice all these concepts, okay. And I will take a live session. We will discuss all these concepts there also. So please don't worry. Now is the last concept of this lesson, the Bayes theorem. Okay, this is very, very important, and here this is the mathematical representation. Okay, so let me explain you what it says. If there are few events e1, e2, en, and those are mutually exclusive events, okay, and then in the random experiment, then for any arbitrary event e of the sample space, we have this formula. Okay, so that means what is it is representing? It is representing that E has already happened here, and now we are searching for happening of another. And here we don't have only two events. Here we have so many events. So we'll use this formula. Okay, I will take two examples here so that you can really apply this theorem, and you can understand what does it mean and how to apply, because it would be more convenient to make you understand with the help of example. So here is my example, and you can see in this example 3 urns contains 6 red, 4 black, and these balls. Let me draw, or there are 3 urns or bags. There are 6 red and 4 black, 4 red and 6 black, and 5 red and 5 black balls. Okay, so now one of the urn is selected at random and a ball is drawn from it. So we don't know which one is selected. So out of 3, if we select 1, so what will be the probability of selection? That would be 1 by 3. So 1 by 3 for each. Okay, so that means if I select this, so the probability of selection of first urn is 1 by 3. If I select this, it is the same 1 by 3, and third is 1 by 3. Okay, so this probability of selection of any urn is 1 by 3. If the ball drawn is red, okay, if they have drawn a ball, don't know from where they have selected, but if they got a ball which is red, then they are finding what is the probability that it is drawn from the first turn. So this is a condition that they have got a ball and they don't know from where they have selected it. So and this type of questions can be solved using a Bayes theorem only. Okay, so here is the solution. So in this solution, first of all, they have used few notations here, like u1 represents the ball is drawn from u1, u2 represents ball is drawn from u2 on earn 2, earn 3, and then they have just written that we have to find probability of u1 and this divide sign r. What it represents? It represents that red ball is there. Okay, they have selected a red ball, it is already happened, and now they are looking for that it has come from earn 1. Okay, so here we will use this Bayes theorem, and this will be the formula. You have to remember this u1 oblique this r, and you have to write probability of choosing earn 1 and probability of getting red ball from earn 1, and now you have to use this formula. Okay, and then you have to get the probabilities of each one. Like I told you that probability of u1, u2, u3 would be 1 by 3. Now the probability of getting red ball when we have selected earn 1, it is, that means from earn 1 we are getting red ball, so it is definitely 6 by 10. Okay, red ball from earn 2, it is 4 by 10, and this way 5 by 10, and finally we will put the values in this formula and we'll get the answer. Okay, please try to understand this question. So then now we are like you please practice, and I will discuss all these concepts, all those questions, and I will also upload a quiz and some practice questions for you, just for your practice. Just if you practice all these questions, then you will get only the confidence how to solve these probability based questions. Okay, so this is the same kind of example, but it is related to now manufacturing defective products. So please try this example as well, try to understand, and feel free to ask your queries, ask your questions. Okay, let me summarize that we have learned in this lesson conditional probability and especially Bayes theorem. This is very very important. Okay, please keep studying, and we'll meet in the live session as well. So okay, take care. Thank you so much.